Hey guys, welcome to day 15, last day of the week. Don't forget all homework will be due tomorrow at noon, with the exception of tonight. Since tonight's going to be a little longer assignment, it'll be closer to 20 problems. I did not think that was fair to only give you 24 hours notice of that, and so I'll actually have that due on Tuesday of next week. I'll give you the full weekend to work on it, plus a couple days during the week, and give you some time to, grade some stuff. So that'll be coming in on Tuesday. That being said, today we're going to talk about a couple of specialty ways you can use factoring, using something called the difference of squares, as well as the difference in sum of cubes. These particular techniques, very powerful once you learn how to use them. If you don't learn how to use them, all it will do is make you slower. It'll make the problems take more time. For the problems that you have tonight, if you fail to use these techniques, some problems you can still do by using things like the AC method that we talked about last time, but some you can't. It's just not possible. Because these techniques are so common, it is strongly recommended that you know what they are and how to use them in a way that is effective. So let's go ahead and get started, and we'll do a bunch of practice problems today to hopefully try to get these right. Do not forget, the techniques from last time still work. They still do. And some of your homework problems are practice from last time. They're additional practice. That's all they're there for. The only difference is you need to make sure that if you spot one of the techniques from today, to use today's techniques in your homework tonight. If you don't spot it, then just use the techniques from last time. They still work. Let's get started. Okay, there are three formulas we're going to talk about today, and they kind of all fit together. So I'm going to put them over here on the side. We have difference of squares. And then we have the sum of cubes and the difference of cubes. As you can imagine, each of these ones are specialty, meaning that if you see squares with a difference between them, then you're going to use a difference of squares formulas. If you see cubes with a sum between them, you're going to use a difference or sum of cubes formula. You have to look to see where they fit in, and let's take a look at them. So for this one, it is a squared minus b squared. So notice that unlike last time, this one only involves two terms as opposed to three terms. So it's not a trinomial, it'd be a binomial. And because of that, it has a special relationship where they end up having a faster way to factor these while avoiding the techniques from last time. For the sum of cubes, a cubed plus b cubed. Difference of cubes, a cubed minus b cubed. Now these two formulas are very similar, so note the differences. For the a cubed plus b cubed, so the sum of cubes, you have a plus b times a squared minus ab plus b squared. And for the difference of cubes, you have a minus b. So there's one change there, where the first parentheses always matches the first sign. So positive b cubed, positive b, negative b cubed, negative b. Over here, the middle term will always have the opposite sign. So plus ab. It's the only change that exists. Okay? And it turns out these are really easy to show why they work. If you were to refoil each of these, you will get the same result. So for example, if I take the function a plus b times the function a minus b, if I use, FOIL, a times a would give me a squared, a times negative b would give me negative ab, b times a would give me positive ab, and then b times b would give me negative b squared. These middle two terms would cancel, and thus be left with just a squared minus b squared. And so we know this technique is going to work. Similarly with the other two, if I was to remultiply them, so if I was to take a plus b times a squared minus ab plus b squared, if I was to redistribute, remember I have to distribute each term, so to take a times a squared, which would be a cubed, a times negative ab, which would be negative a squared b, and then a times b squared, which would be positive ab squared. If we do the top ones, b times a squared would be positive a squared b. B times negative ab would be negative ab squared. And then b times b squared would be positive b cubed. And you can see the negative a squared and the positive a squared are going to cancel. The negative ab squared and the positive ab squared are going to cancel, leaving just a cubed plus b cubed. So we know it works because we can easily show it, and the difference works much the same. And so the trick with these kinds of problems is, can we spot which one? And then if we can spot which one, can we determine what A is, and can we determine what B is? For today, we're going to try to get through, hopefully, at least 4 of these, but we'll see how far we get. We've only 24 minutes remaining. Let's see what we got. Let's start with the difference of squares. So in this one, we have the basic one, x squared minus 169. This is our first example. Now, for this example, you have to notice that it's difference of squares for this to work. And if I notice this difference of squares, I notice that my x is going to be equivalent to my a. Because in my problem, I have x squared, so my a would be our x in this example. And our b, in this case, would be 13. Now, the quick down and dirty way to find a and b for the first one is to square root. If I take the square root of x squared, I get x. If I take the square root of 169, I get 13. So it makes sense that we should get those pieces to match. On the other hand, if not, you can just memorize your tables, but that's more fun. And so the easy way to do this problem is to just do difference of squares. Okay, so this tells me that if my a in this case is x, my b in this case is 13, that tells me that this function is going to be equivalent to x plus 13 times x minus 13. And this always applies, and don't forget, because of how multiplication works, you could also do it the other way, and you get the same result. So either one of these would be correct, and they're both just difference of squares. So again, it's about, can we find the x, or a, can we find the b, which is 13, and then can we plug into our formula. And notice how much faster this is than doing the techniques from last time. Like we did the techniques from last time, we had to take negative 169 times 1, which is negative 169. Then we need factors of 169 that would add to 0, because you notice in this problem we don't have any middle terms. And so my b would have to be 0. And don't confuse the b in the formula for the b from, ax squared plus bx plus c. These are two different a's, these are two different b's, okay? This ab comes from this formula, whereas this ab comes from a different formula. In mathematics, we often use the same letters to mean different things. Like a doesn't stand for acceleration just because it starts with a. Let me put it that way. And so this is an easy way to always shortcut your process. And do note that it does work, because if I was to refoil these, which remember is always an option, I would take x times x, giving me x squared. I take x times negative 13 and get negative 13x. I take 13 times x and get positive 13x. I take positive 13 times negative 13, giving me negative 169. The middle two terms would both cancel, leaving me with x squared minus 169, exactly where I started. So these two both work. So another example. 9y squared minus 25. Okay, in this case, the trick becomes, okay, can I determine my a? Can I determine my b? If I see only two terms, I'm probably going to use one of these three, because these three are special. They work best whenever you have one of these types. And so I look here, I see that I have something being squared, so I'm probably going to try to use difference of squares. And so my goal becomes, okay, what's a, what's b? In this case, my a would be 3y. How do I find that? Square root the 9y squared. The square root of 9 would be 3. The square root of y squared would be y. How do I get to b? Well, it would be 5, because that is the square root of 25. And so this tells me my a would be 3y, my b would be 5. And now I just plug into the difference of squares formulas using my a and my b. So I take my a and my b, I plug them in, I would get 3y plus 5 and 3y minus 5. Or alternatively, because remember, order isn't that important, 3y minus 5 and 3y plus 5. These both are the same thing. And again, this is the last time I'll do this, but I will do it. If I was to redistribute, I would get 3y times 3y. 3 times 3 would be 9. Y times y would be y squared. 3y times negative 5 would be negative 15y. That looks like it's going to be a problem, because there's no y's in here. But again, if I keep going, 5 times 3y would be positive 15y. And so you can see those two are going to cancel. And then 5 times negative 5 would be negative 25. The negative 15y and the positive 15y are going to cancel, leaving 9y squared minus 25, exactly as we expect. For my third example, you kind of see how this all fits together. Let's do 361 x squared minus 100y squared. Okay, let's do it. So first things first, we need to determine what the a and the b are going to be. So for a, remember you find that by taking the square root of 361x squared. To find the b, you do the square root of 100y squared. So the square root of 361 should be 19. The square root of x squared is x. Square root of 100 is 10. Square root of y squared is y. There's my a, there's my b. I can now plug into my formula. My formula states I take a plus b times a minus b. Or I could do the alternative, 19x minus 10y, 19x plus 10y, the same thing. Either one's acceptable. So this is how we kind of approach these problems. Our goal becomes finding a and finding b. Once you find a, once you find b, you can then use that to determine what the two pieces are going to be by simply plugging and chugging into this formula. Again, I cannot stress enough, the a and the b from the formula is different than the a and the b from the equation. These two are different things. They are. We find these manually by using square roots. We find these by just looking at the formula. Okay, so these are three really good examples of using difference of squares. Notice how they vary greatly between how we can approach them, right? If the initial value has a coefficient of 1, we can still do it. Just x squared becomes x, 169 becomes 13. And then we plug x plus 13, x minus 13. If the initial value is not 1, so I have 9y squared, then we again just take a square root. The square root of 9 is 3, square root of y squared is y, square root of 25 is 5. 3y plus 5, 3y minus 5. And even if there's more than one variable, it still works. I'm going to do one more. Like supposing that it's even weirder. There's not one like this in your homework, but I think it's good to see. What if you had like x to the 6th minus 144 y to the 4th? These don't look like they can use difference of squares because they're not squared, right? We have x to the 6th, that's not squared. We have y to the 4th, that's not squared. So are we stuck? Like, what can we do? Well, it turns out difference of squares still works. Because if I use a, I would take the square root of x to the 6th. The square root of x to the 6th, remember, would be x to the 6 over 2, which would be x cubed. And so there is a square there. For b, I take the square root of 144 y to the 4th. Square root of 144 is 12. Square root of y to the 4th would be y squared. And so, yeah, I can still do difference of squares. I'd have x cubed plus 12y squared and x cubed minus 12y squared. It just works. That's why we can show the formula. Because it works with the formula, it'll work with any pieces that are plugged into that formula, no matter how complex those pieces are. As long as these are even powers, essentially, we can use difference of squares to simplify them. Now, if there's a plus sign between these techniques do not work. Instead, you should look for things like a greatest common factor. That'd be the biggest one to look for. Or see if there's some other way to factor this. Because this one works specifically when it's a difference of squares. Remember, difference is the key word there. Difference meaning subtraction. And we have subtraction here. Okay, now let's talk about our other two formulas. The sum and difference of cubes. These are about the same, but the formulas are just a little more complex. And so let's take a look at some examples. Okay. First example. Let's see. X cubed plus 512. All right. So, I look at this, I see a plus sign between them, which means difference in squares is out. I cannot do the top one, because first of all, there's not a difference, it's a plus sign. And secondly, they're not squared, right? This is x cubed, that's clearly not x squared. Like, with this one, it was working because we had even powers. But with the cubes, they really have to be cubes to work well. Now, the 512 is a great question mark. My goal, just like before, is to recognize what A is and what B is. Now, if you have a calculator, you could just do a cube root. The cube root of x cubed is obviously going to be just x. The cube root of 512 should be 8? Yeah, 8. Or, like, you could just take the cube root manually if you needed to. Like, you could just do, you know, the cube root of 512 becomes, let's see, 512, I'll do it over here. Like, if you had to, you could do it manually. This is 2 times 256. 256 is 2 times 128. 128 is 2 times 64. 64 is 2 times 32. 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. This ends up being the number 2 written out. 1, 2, 3, 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. And then we group 3s. So there's 3 2s. A 2 will pop out. Another 3 2s. A 2 will pop out. Another 3 2s. A 2 will pop out, which is why we get 8. So again, you always have the option to go back and do it manually, but a calculator just makes this process a little faster. And so now we can plug into our formula. Our formula says the sum of cubes. The first parentheses is just a plus b. So my a, remember, is x. My b, you'll recall, is 8 from right here. And the second parentheses, it says we have a squared. So if my a is x, that means I would have x squared minus a times b. Well, 8 times x would be 8x plus b squared. 8 times 8 would be 64. And so this ends up being our factored version. Now you should double check to make sure if this is going to factor. Usually it won't, but do double check by using any of the techniques we talked about before. But this is how you factor it using things like the sum and difference of cubes. You have to first make sure they actually are cubes. So we took the cube root of our first term to get x, cube root of our second term to get 8, and then we plugged in to find out if they actually worked. Let's do another one. We'll do one similar. Let's do 216x cubed plus 8y cubed. Okay, just like before, our goal becomes to find out what a is and what b is. Okay, so for this first one, I would take the cube root. Remember, it's a cube root because it's the difference of cubes. 216x cubed. For b, it'd be the cube root of 8y cubed. The cube root of 216, I know that one, it's 6. The cube root of x cubed is x. Here, the cube root of 8 is 2. The cube root of y cubed is y. So this tells me my two pieces are a and b, are 6x and 2y. Let's plug them in. In the parentheses, we take a plus b, so 6x plus 2y. Now here is where we have to get very particular, because according to the formula, in the second parentheses goes a squared. So that'd be 6x quantity squared. So in this case, my first piece would be 36x squared. Remember, we had to square the 6 and the x, giving me 36x squared, minus a times b. If I take 6x times 2y, 6 times 2 is 12, x times y is xy, plus b squared. I take 2y, I take the entire thing and square the whole thing, so that'd be 2 squared, which is 4, y squared, which is y squared. And again, if you are concerned that you didn't do this step right, or if I dock you points, you're like, why did I miss points? Just check it. If I take 6x times 36x squared, 6 times 36 is 216 x cubed. If I take 6x times negative 12xy, this would be negative 72 x squared y. I take 6x times positive 4y. 6 times 4 is positive 24 xy squared. Now to the bottom row, 2y times 36x squared, that'd be positive 72x squared y. Look at that, those two are going to cancel. I take 2y times negative 12xy, this would end up with negative 24xy squared. And then 2y times 4y squared, this becomes 8y cubed. Notice that those two terms cancel out, leaving us with 216x cubed plus 8y cubed. Exactly what we started with. And this always works. So please, if you're struggling with these, check your results. So we've done two now with different, or sum of cubes. Let's do two with difference of cubes. For this one, let's do this one, example. 8x cubed minus 125. So again, our goal becomes, we determine what a and b are. Now if you have some of your cubes memorized, you can shortcut this process a lot. For example, I know the cube root of 8 is 2. I know the cube root of x cubed is x. So I don't need to go through the process of doing a cube root manually. The 125 would be 5. Again, that's one that I have memorized, and it's worth memorizing. So, with difference of cubes, just take a look at our formula right there, I take a minus b. So my a is 2x. So 2x minus b, so that'd be minus 5. Okay, so that's a minus b, parentheses, a squared, so that's 2x quantity squared. So that'd be 2 squared, which is 4x squared, which is x squared, plus a times b. A is 2x, b is 5, 2 times 5 would be 10, x is x. And then the last one is b squared, so that would be 5 squared, 5 squared is 25. Now, in years past, I have seen students, before I forget, this is the correct answer. I have seen, like, the crazy ones. I'm not saying that you're crazy if you do this. I'm saying you're weird, and that's okay. They would, like, put 2x squared, because that's your a squared, plus, 2x times 5, right? Because that's your a times b, plus your b squared. I just think that this gets very nasty very quickly because you have so many parentheses. I prefer to just do it one piece at a time. And notice how every time I do it, I always do number part first, variable part second. So like whenever I got this result, I had to square a which was 2x. So I did the number, 2 squared is 4, then I did the variable, x squared is x squared. The middle one is a times b, well that's 2x times 5. 2 times 5 would give me the 10, and then x would be x. The last term is plus b squared, 5 squared, 25. It's just a little faster than trying to do it by hand. And a little less intense with the parentheses, right? There's a lot of parentheses in here. I find I make more mistakes doing it this way than I do doing it this way. But hey, if you're the kind of person that could do it this way and get the right answer every time, then do it that way every time. I got one more here. 1000x cubed minus y cubed. Okay. In this case, let's talk about A and B. My A would be, okay, the cube root of 1000 is the cube root of 1000x cubed. I know it, but just reminding myself, this would be 10x. The cube root of y cubed would be just y. And so now I can plug into my formula. My formula says A, 10x, minus B, y. Second parentheses, A squared. So I take 10x and I square it. That would be 100x squared plus A times B, so 10x times y, which would be 10xy, plus B squared. Y squared would be y squared. So you can see how fast this gets compared to the problems from last time. And again, not every problem tonight will use a shortcut, but now shortcuts are available to you, so use them when appropriate. You can only tell by looking at them. You have to take the approach to finding these pieces and doing these pieces. I know I went over time last time, so I'm going to cut it here off here. We'll talk about our last piece of this section on Monday, which is doing fractional powers. It's a fun one. Remember, this homework assignment is a little bit longer, so we'll be due on Tuesday instead. Otherwise, that is it. Hope you guys have a good weekend. If you remember you need me, I'll be in the chat tonight, this afternoon I should say, and I'll see you guys then.